Physics. Happy Wednesday. I'm really proud that you went on to Schoology, you looked at the worksheet. I'm impressed that you managed to print it out. I don't know how you managed that. I don't even have a printer at my house. So great job, nice work. I looked at both of your submissions and they look awesome. We're gonna do some corrections together. So I have my whiteboard. This is actually Rihanna's whiteboard. Rihanna, if you're watching this, took your whiteboard home. So I couldn't have something to write on with Expo marker. So I'm going to be correcting this together and putting the answers up here. And I would like you to take out those printed pages that you managed to print out and just follow along and correct it with me. So today's class is going to be a really easy one. There's no new work for you. We're just going to be correcting the work you already did. All right? Okay. And we're going to do number one together. Number one that I told you to skip. Okay. So number one, I want you to look at your worksheet and I'll put it over here. Can you see this? Yes, you can. Okay, so number one has something like a mirror. And we're getting an incident ray and a reflected ray. And this is a really easy question to get right on your regents. It's so easy because you're going to get something called a protractor. And all you have to do really, you just have to measure the angle between them. And let's say this is an even 40, now let's make this a 50-degree angle, okay? So let's say this is a 50-degree angle, and you have to put the normal between them. Now you know that the reflected angle with the normal has to be the same as the incident. So what you would do, you would put the normal line strictly down the middle, 90 degrees with the mirror, so that each side is equal. So you'd have 25 this way and 25 this way. Boom, that's it. And that answers both 1 and 2. 1 says using a protractor and ruler, construct and label the normal to the mirror. The normal is the vertical here. I know it's a crooked line, but it's supposed to be straight. At the point of incidence at the given diagram. And B, using a protractor, measure the angle of incidence. The angle of incidence is the same as the reflected angle. This is your angle of incidence. Now, since you don't have protractors, I'm not asking you to do this, but that's how you would do this type of problem, okay? All right, number 2. Determine the wavelength of the ray of light shown in the diagram. Show all calculations, including the equation and substitution with units. Beautiful. All right. So the equation we're going to use is velocity equals lambda f, like that. We're going to substitute all of them using our units. And this was something we're going to work more on. We're going to work on more using units inside of our equations. Let me skip this so you can see more. All right, so what do we have here? We have, okay, so our velocity is going to be the speed of light. And the speed of light we get from page 1 of our reference table, 3.8. 3 times 10 to the 8th power meters per second equals, what's lambda? Lambda is what we are finding. That's a wavelength, okay. And the frequency is 5 times 10 to the 14th power. Now, I think both Ashley and Claire, I think you both did this right. You both divided, I looked at Claire's more, I'm sorry, Ashley. I looked at Claire's more because she submitted it this morning, so I had more time to look at it. By the way, I'm not going to be online Wednesday morning because I'm volunteering to distribute food. So if you need help, I'm going to be here. I'm going to be online Wednesday afternoon, like afternoon, like from noon to 3. I hope I'll be done by then. Okay, so 510 times to the 14th. I divided each side by 5 times 10 to the 14th. 3 divided by 5, I got 0.6 times 10. Remember how to do this. This is 8 minus 14 because they're dividing, so it becomes a minus 6, and this is equal to 6 times 10 to the 7th power. That is my meters. That is my wavelength right here. Right here. Those birds chirping, that's my bird clock. I have a Brazilian bird clock behind me. Okay, so that is number 1 and 2. Hopefully I'll get a third one before I have to erase. What is the color of a ray of light? Okay, so I know I saw Ashley had a question with this one. This one actually, if you find a frequency in a question, the frequency, we're still talking about question number 1, and the frequency is 5 times 10 to the 14th hertz. And then you would go to your reference table. Let me pull that up here. And let me turn this around so you can see it. Okay. So you see this? And you would see that 5 times 10 to the 14th. Is that it? Was that what we started out with? 5 times 10? Yeah, that is what we started out with. Okay. 5 times 10 to the 14th. That is a yellow color. That's between 5.03 and 5.20. So Claire answered yellow, and yellow is the correct answer for this one. There's no calculation with that one yet. Okay, back to the exercise, and let's get one more. Let's do number 4. Oh, number 4 is a long one. Okay, so I'm going to cut the video here. I'm going to erase, and then I'm going to set up number 4. Hey guys, so this is number 4. It starts with a diagram like this. And now this is like completely new information. So I would like you to actually take out your notebooks and draw this in your notebooks, or draw this on a piece of paper somewhere where you can like follow along with me, because this is new information for you, okay? So we're going to be working with Snell's law, and Snell's law is this right here. It's N1 sine theta 1 equals N2 sine theta 2. And now this is completely new for you. I'm going to show you where I found this on your reference table. Let me scroll down. It is on page 5. So take your reference tables out too, and pause the video if you have to. Okay, so over here, hopefully you can see that. Can you see? Am I pointing to the right place? Over there? Okay. So I can't ever see if I'm pointing to the right place. So it's on page 5. It's above modern physics, and then there are things like N2 over N1, etc., etc. So it's N1 sine theta 1. So this angle right here. This is called Snell's law, and what it is, it's the law of refraction that we read about on the yellow packet, the last one that I gave to you last week. So what it is that light, when light travels, and light, just as a reminder, it could be a radio wave, it could be a microwave, it could be an X-ray. Those are all light. Radio is light, so just not to confuse you there. It's all traveling at 3 times 10 to the 8th power, unless it goes through different mediums, which it is. And right now our light ray is moving at 90 degrees to in our air. It's moving at 90 degrees. It's forming a complete perpendicular angle, and as it goes into the water, it's going to slow down. And not only is it going to slow down, it's going to bend. In the video that I posted on Tuesday, you saw that there was like an optical illusion of like the pen being bent when it is put in water. Well, that's what's going to happen. My ray now is going to go through the water at a bent angle, and the image is going to appear distorted. But I don't know what this angle is. If I keep drawing the normal here, I don't know what this angle is. I'm going to call this angle theta 2. This angle right here, 90 degrees. I can tell that by looking at the diagram. This angle, I don't know, but I would have to draw it right. So let's figure out what that angle is. My N1, first of all, N represents now let me put this up in your reference table. It represents an absolute index of refraction. Refraction is when light slows down as it goes from one medium to another. So that's what N is. And if you look at page, I'm going to tempt this again, turn this around so you can see it. And can you see? I need to tilt it more down that way. Okay. Can you see that? It's on page 2 of your reference table. Okay, back up a little bit. And you'll see that all those values there, they're their N's. And the value for air is 1. 1 has air, and air is 1. So our N1, in this case, I have, let me put this in another color even though it'll be clear for you. Okay. So I have N1 here, and I have N2 here. And my N1 happens to be air, which is 1. My theta 1 is the difference between my light, my incident ray, and the medium that it's in, and it has a difference of 90 degrees. So It happens to be 90 degrees for this first one. Hey, Bella, calm down. My N2 is 1.33. And my theta 2 remains to be determined. So plugging in, now I'm going to use this equation over here. I'm going to rewrite it with the values. N1 sine theta 1 equals N2 sine theta 2. N1 is 1, so, and sine of 90 degrees is 1. So 1 times 1 equals N2 happens to be 1.33. I got this N from page 2 of your reference table. It says that for water it's 1.33. I put expo mark on my computer. Oops. Times sine theta 2. So then I should get that the sine of theta 2 is 0. What did I get here? 752. And if I put the inverse sine function in my calculator, I'm going to get a theta of 48. Can't even see there anymore, can you? Nope. I'm going to get a theta 2 of 48.8 degrees. I'm sorry it's really slanty at the end, but, and that's what we would draw here when we're drawing this bent angle. Then we would draw it with an angle of 48.8 degrees with a protractor, which you do not have. I'll put it right here. Can you see that? Okay, so this is how you would do number 4. Let's do a couple more out while the camera's rolling. Number 5 says that you have a wavelength and you're trying to figure out the frequency. Let me tilt it a little bit and put it here at the blank spot at the whiteboard. So number 5, I think both of you got this right, but I'm going to do it anyways. Lambda is equal to 6.21 times 10 to the minus 7th. Tilting up so you can see what I'm writing. Velocity equals lambda f. 3.10 times the 8th meters per second is equal to, oh, now let's start to erase this part. 6.21 times 10 to the minus 7th. I'm forgetting the frequency, times frequency. So frequency, you would divide both sides by 6.21 times 10 to the minus 7th. Oh no, I think you guys, one of you got this wrong. I forget who. But it was by a really slight error, and I remember. Okay, so you divide both sides by 6.21 times 10 to the 7th to cancel it out on this side. And then on this side, you have 3 times 10 to the 8th meters per second over 6.21 times 10 to the minus 7th meters. And then you would do 3 divided by 6.21 and you would get, I got 4.83 times 10 to the 14th power. And I think you guys got something a little bit different, but since I got 4.83, that puts me in the orange. That puts me in the orange spectrum. And how do I know that? I went to my physics reference table, and up here orange is between 4.82, so it's barely greater than the orange. It's so it's between my orange and my yellow, so it's in the orange. Ooh, now I turned it upside down. Hope that's not gonna affect the camera. All right, now let's try to do a couple more. Number 6. Let me get a rag so I can erase. Put more lice on this rag. Number 6, kind of the same type of question. Number 6, same type of question. We're still using this same formula. Velocity equals lambda times frequency, or frequency times lambda, and then we have 3.10 to the 8th meters per second is equal to the lambda, which is 6.21 times, no, I just did this one. 6 it's 6, not 6.21. 6.0 times 10 to the minus 7. Divide both by 6.0 times 10 to the minus 7. 6.0 times 10 to the minus 7. And you're going to get a frequency of 5 10 to the 14th power. Okay. The question number 7 says, why is UV light more damaging than visible light? It's because UV light has a smaller frequency. I think you guys got the idea. Maybe the wording was a little off, but UV light has a smaller frequency. It's smaller wavelength, higher frequency, smaller wavelength, higher frequency. Therefore, it's a smaller wavelength can penetrate our cells and mutate our cells. That's why it's more damaging than visible light. For number 8, I don't have number 8 written down. I don't know why. Let's go to number 8. Based on it's on the graph. Okay. Which color of visible light has the lowest intensity? Both of you got this one right. That's why I skipped it. Okay. Number 9. It has been suggested that fire trucks be painted yellow, green instead of red. Why? Instead of answering this, I'm going to go straight to what Claire wrote. Again, I spent more time on Claire's because she handed it in this morning. And I'm going to read you Claire's because it was such a perfect answer. I'm just going to read it out loud. Claire said, yellow and green have a higher frequency than red, but a lower frequency than violet, making it fall in the middle of the graph, which means it has the highest intensity. That's a perfect answer. To add to Claire's answer, we see visible light mostly in yellow and green, and that's why we think that we should paint fire trucks in yellow and green, because we see that more. We see those colors more. Okay, back to number 11. 11 is kind of the same thing as number 6, so I'm going to skip that one. For number 12, careful, the speed of X-rays and speed of radio waves are the same, or any type of light really, they're both the same. For number 13, the answer is C, speed. For number 14, it is also C, electromagnetic, transverse waves. For number 15, the answer is UV light. Let me see if I need to slow down on any of those. I forget the actual question. Going to the actual question. Which one? 14, 15. Yeah, careful on number 15. It is UV light, 1.3 times 10 to the minus 7th meter. Go to the wavelength part of your physics reference table. There's a frequency part and there's a wavelength. Go to the wavelength. It's actually UV light. For number 16, a beam of green light. You got this right. It's A 6 times 10 to the 14th power. And 17 electrons with a frequency of 2 times 10 to the 10th hertz produce electromagnetic waves, which are microwaves, type of radio wave. Okay, this is a long video. I'm sorry. I hope you followed along. I hope you took some notes. Great job on your assignment. I was impressed. I was honestly impressed by how you printed it out. You responded promptly, and you submitted it and uploaded it, and you got them right. So I am impressed. Tomorrow there will be more work. Today was just note taking and correction taking. So good job. Stay healthy, everybody. Remember to opt out of meals if you don't want meals, because that makes our life easier. That means that that's less time, and that's less stops that we have to do on our bus route. And tell your friends about that too. Yeah, that's all I've got. If you have any questions, let me know. Bye.